Okay, hello everybody from all over the world. I shall start my presentation with a question. Please don't use Google because now you all have it under your thumbs, but do you know what is the most forested country in the world regarding the area under forests? Does somebody know? Please write it in the chat and I shall look the answers little bit later. Why I'm asking this? Because Slovenia is the third most forested country in the European Union with over 60% of forest. And I will have a presentation talking about papers which are not made mainly from wood-based fibers. I shall try to give this story with a little bit twist to think more about sustainability and some options which are basically lying around us, even if you don't have such large quantity of wood fibers or forests like, for example, Slovenia, Sweden, or Finland, which is the champion in the most forested country in the European Union. So I will talk about circular fiber sourcing, what are the basic requirements for papers, runnability of papers made from so-called alternative fibers, printability of papers made from alternative fibers, and I shall present use cases of printed and packaging products made from invasive plants and agro-industrial residues. And of course, at the end, like Ivana is doing very good, question and answers. I work currently at the Pulp and Paper Institute. We are very, very old institute, more than 70 years old. I heard at another webinar that FOGRA said we are almost 70 years old. We are older than FOGRA. We do a lot of R&D. We also do services, basically from fiber sourcing, characterization, paper maker, printing, packaging to food contact, lots of stuff. What is special about us that we have a pilot line for paper making and we are producing our own paper. You have the paper machine characteristics here. It's not a big machine, it's a small machine if you compare it with the big paper mills, but it's still producing papers, and I shall present some of our products a little bit later. So from where can we source fibers for paper products? Here are the most common sources we are using today. Of course, forest, where we can source hardwood fibers or softwood fibers. Then we have recycling sites. The paper industry has one of the best recycling and repurposing systems. Then we have crops. We have agricultural residues, and we have, for example, industrial waste like old rags or some other clothing industry which also uses fibers. For example, European Union is currently using 46% of fresh wood pulp fiber and around 54% of recycled fibers. So it's around 50-50%. Wood is the most and common use source for fibers because you have all year round availability. It is replenishable and can be used also for energy, for chemicals, and for many other things. I will speak a little bit about that. So why would we use other type of fibers if forests are very good source for fibers for paper making? I also can say, for example, that softwood and hardwood type of wood species have around 95% of fiber content in their structure, and for example the other crops are below 50%. So also regarding yield, forest is a very important source for fibers. If we talk about non-wood fibers, like a special story, alternative fibers, we have 4 types of non-wood fibers. We have on so-called on-purpose fibers, agricultural residues, industrial residues, and naturally occurring species. And for example, the on-purpose dedicated crops are grown specifically just for paper fibers. If some country is lacking wood fiber, it is destined to grow specifically other types of fibers, which are so-called non-wood fibers. Then we have the agricultural residues, which come from field or harvesting residues, and are materials which are left in the agriculture field or the orchard after the crop has been harvested. And then we have industrial process residues, like rice husk, hemp residues, peanut crust, cotton liners, and for example, flax residues from oil seeds. And new type of fibers which is coming is invasive plant species fiber, beside the common papyrus, bamboo, or grassroot fibers. If we look at the structure and trends of the non-wood fibers, the whole ratio of world production is around 5%. So 95% is wood-based fibers. 5% of fibers are so-called non-wood. Mainly, as you can see on the map, it's concentrated in South America, China, and some part of Asia, and Mexico, where lots of eucalyptus is grown, which is used as a very good fiber source. If we look the non-wood pulp in the fiber production, the most dominant is straw. Straw is used around 45% of the cases. We can see bamboo, 20%, bagasse, reeds, and other types of fibers. Why we want to use another kind of fibers if wood has so much good opportunities and a high yield, high fiber content, very good quality? Because there are some changes happening in the world, and that is the transformation of the paper mills due to some declining of the paper production, classic printing papers, into so-called biorefineries. The biorefinery, it has a paper or fiber as one of many outputs in production. So basically you can use the wood or other kind of biomass to have energy. You can have biosolvents, biochemicals. There are a lot of people going into also crops for bioplastics. You have oils and many kind of different products you can take from biomass. For example, the Nordic countries are going very much now, because there is, as I said, a decline in the paper production. They are going into biomass energy, and in the future there will be some kind of war for resources regarding which is better to use the wood, for example, for energy or for fiber making. Of course, fibers are not just used in pulp and paper production. You can also use it, for example, in biocomposites, where you can, for example, take out 30 or 40% of plastics and replace it with fibers, and then you can call it biocomposite. It's a kind of middle of the way solution of reducing plastic pollution. So, as I mentioned, invasive plants are a new kind of fiber source. Invasive species are species that are not native to a country or a specific location, and it spreads very quickly. Where they come from, mainly they can come from, for example, somebody takes some plant from another part of the world, puts it in the garden, and the seeds are going around, and it starts spreading with no control. There is environmental, human economy, also human health issues with this kind of invasive plants. That's what they are called. But we have to be also fair with some kind of invasive plants like the Japanese knotweed, which you can see on the right picture with the orange West guy. It's, for example, they have very, very deep roots and they're very hard to take out. You have to dig up everything to get rid of this kind of invasive plants. But on the other hand, because of their root system, they're excellent cleaners, purifiers of the soils. They are sucking up heavy metals from the soil, and you can clean, for example, some sites which have a heavy metal industry or some other industries which are polluting the soils around, for example, housing. So in some parts you can use them very wisely. And we tested these plants for paper making. Why we thought that these kind of fibers are interesting? Because with some new technologies and a good municipal system, you have a good new source of fibers. For example, urban green cuts or municipal waste here in Slovenia. When you do your gardening, you can put the rest, or for example, composting in your garden, or you can put in a bin, and then it's taken to the composting site, and the municipal company which does the waste management sells back, for example, half industry made compost. Another thing is that there is a community crowdsourcing system in Slovenia. For example, here is a map where all green dots are regarding invasive plants. So you have a website, you log on, you take a picture, your telephone is GPS coordinated, and then you have a specific location of these crops. And for example, if you want to harvest these kind of crops or to make some kind of voluntary action, you know exactly in which position, which quantity of this kind of plants or fiber sources are available. So this whole story is regarding sustainability, of course, with some marketing. One of the trends we noticed here in Slovenia is that the brown is the new white. So what do we mean that brown is the new white? These papers are not the high gloss, ultra white papers which some people prefer or some market segments, but for people who consider sustainability more than appearance. We also noticed in talking with lots of designers or marketing studios, which are also ordering this kind of papers, that recycled paper is just not cool anymore because it's a commodity. Because the paper industry already can replace up to 100 of fiber content with recycled ones. So if you have a recycled papers written on your packaging, it's common, it's nothing special. For example, some paper producers also use some kind of marketing, as I said. They are adding 10 to 20%, for example, of leather particles or orange peels or other additives in the recycled content from the waste paper collection schemes to form new value proposition, and they have some kind of new stories. This approach can be taken towards a more circular economy, where the fibers and the fillers are sourced from the industrial processes or the agriculture residues, and they have a story. And we as a people love storytelling, and as I said, recycled paper has a story, but it's passé because it's sourced from different kinds, and basically you don't know the roots of the fibers. And with this approach that we are promoting, you know exactly where your fibers come from. You can also make your process more circular. You can close the gap. For example, if you use your residues from your industrial processes or agriculture processes to make the packaging for your products, or for example, promotional brochures from it, and this adds additional value Why? Because you're closing the gap, you're not throwing away good fiber sources, and on the other hand, you're lowering the demand for fresh fibers from high-yield industry pulping. For example, eucalyptus has to be transferred from Mexico to Slovenia, which has a lot of woods, but needs some kind of other type of woods. And I don't know how green is that you're outsourcing type of fiber from another part of the world. I shall give two examples where we collaborated and tested. One is from industrial process waste. It's jute bags from a coffee producer, which is the largest in the region, and they're used for transportation from Brazil, and they are currently burned. They don't know what to do with them, and there is a lot of these kind of bags. They are also looking for repurposing of upcycling these jute bags. For example, they made with some designer clothes and bags. And we made some papers from jute bags. I will show them a little bit later. And for example, we also collaborating with the largest tomato producer in Slovenia, who is giving us his tomato stamps. Somebody would say, why is he giving tomato stamps? He can use it for composting. Yes, but he uses aquaponics gardening system, so that means he doesn't use soil for growing tomatoes, and these tomato stems are pure agricultural waste, and we use that to make boards, and his tomatoes will be packed in packaging made from his agricultural waste, and he's closing the circle material flow. So how do you make a paper which you can print on? To be honest, every paper mill has its own recipes, which are kept in a very secretive little black books. There are some general rules, but as we are all living in a price-driven economy, the components are ever changing, because you're always looking for cheaper and cheaper solutions. And regarding some standards, what are the characteristics for printing a paper needs to fulfill? There is a German standard then regarding offset and graver printing, but many of the analytics and properties in these standards are paper-based. The measurement instruments are mainly from the paper industry, and the printer just cannot check it at his side. And it's up to the paper maker to ensure that everything runs very smoothly. So is it really so complex to make a paper? Why we all have this discussion? This picture is unfortunately in Slovenian. I hadn't time to translate it in English, but I pinpointed for our paper making school all the positions in digital printing systems where a badly engineered paper can cause runnability or printability problems. What are runnability problems or runnability? Is the paper properties which determine how paper performs on press. It's basically that you don't stop the press, that you don't cause production downtime, and that means that the paper has to have good mechanical properties. So no curling, elongation, tearing, swelling, anything that can cause jamming. Also, for example, in offset printing, you are not allowed to have any detachment of fibers or particles which can contaminate the printing system. Also, for example, in flexo, if it sticks to your printing plate, then you will have problems on the prints. Printability is the factor which are most printers interested, because here all the CA, LABs and the delta E values are coming from, and the whole science of color management is based practically on the optical properties of paper, and optical property of papers are coming from the light, the ink and the substrate of the paper, which holds out the ink components on the surface. If we look the fibers and their properties on the final properties of the paper, you always have to have some kind of combination of non-wood grades and wood grades, because you have to combine the so-called long fibers or the short fibers. Every type of fibers have some kind of positive and negative properties, and non-wood grades have several challenges, I can say. For example, they are mainly shorter than the softwood fibers, which are very good for opacity, very good for printability, very good for structuring, while the long wood fibers like the pine, spruce are very good, for example, for mechanical properties. So basically, we are also mixing each type of these papers to gain good properties. So these kind of non-wood fibers, can they handle printing? As I said, 50% is the maximum yield of the fiber content, and they have some other parts in the structure like parenchyma, epidermal, and other vessel cells. And because of this, for example, these can lead to dewatering and runnability problems and very low paper stiffness. And for example, because these particles are not bonded so good, you have to be very careful that you don't have problems with linting, which you have the detachment of fibers which are going through the printing units and causing, of course, a machine downtime and stops. It basically goes down to the production matrix. Here is the matrix. What can you do to improve these things? You can, for example, if you want to have a higher opacity will give you a better ink holdout and less print show through. Then you can go up with the basis weight. You can go up with the caliper. If you add fillers, also you're filling in the voids between the fibers. You can also increase the opacity, but you are losing on the caliper, stiffness, and tensile. And a good paper maker has to know this matrix to adjust all kinds of papers for good printability. I will show now some use cases which are done on our institute. We have made and tested papers from miscanthus, tomato stems, seed bags, and we also made 3 types of invasive plant paper from Japanese knotweed, Canadian goldenrod, and black locust. You can see it on this picture. So what's the value proposition, or what's so special here? You can see here a collection of paper products which are made from invasive plants. Is from a project Applause, in which ICP is involved. And here you can see, for example, a puzzle game for children or tourists made from invasive plants which are harvested from Ljubljana region. We also made some brochures. We also made memory games. We also made some paper tubes. As I said, the circular and the sustainability story here is, for example, when you come to Ljubljana and you buy or get a present like this, you know that large percent of the fibers or the raw materials which are inside these products is locally sourced. So it's harvested, it's processed, made and printed in Ljubljana, from fiber to the final packaging. So so that means it's not some kind of pulp from other kind of world. So this is a local story where, for example, some local species will be saved, and those, for example, Japanese knotweed invasive paper will be repurposed, for example, for paper products. We also tested this kind of papers, for example, for printed electronics. We did a lot of testing regarding printability and printing. because we saw a very negative trend that paper producers wanted to go on the bandwagon when the printed electronics on paper started, and they started to coat 2-3 layers of additional coating on papers just to have the smoothness like the plastic. As I sometimes say that paper has a secret wish to become a plastic. But for example, we tested, for example, for electrochemical sensors, and we got very good results that you can use these kind of papers if you, for example, compare it to commercial high-yield pulp paper. Of course, these papers are not for high-end, very tight circuitry, but for some basic and less demanding applications, invasive plant or agriculture residual paper can be used as a substrate, for example, also for printed electronics, for RFID, NFC, or kind of tags. Also, I have to point out on some problems when using this kind of sourcing. There are hidden problems because when you harvest something or you get it from industrial processes of waste, there are some hidden problems. And for example, we found a hidden problem with the youth bags. We tested digital printability of all these kind of papers. And for example, if we would just measure the LRB value or the mottling, for example, youth paper was very good. It has fantastic LRB results, delta results, and everything. But when we tested toner adhesion, we had a lot of problems. And as you can see, the tape pull test was very bad. Then we checked the surface energy, and we saw that it's very low. It's below the requirements for good printing of papers, which is around 25 to 60 millijoules per square meter. And then we got to the laboratory, and we saw that the youth bags fibers were most probably pre-treated in Brazil with water repellent substances to not to attract too much water that the coffee doesn't stain during transport, and this lowered the surface energy when they were used for paper making, and they made problems, for example, in digital printing because of the very low surface energy. So what are the challenges working with this kind of papers? Something from our side. As fiber sourcing is made from different locations, cellulose content and some morphological features varies. It's season dependent. So sometimes the color is changed, sometimes the cellulose content is changed. So this is not a very controlled process. The variations are slight, but again, it can make problems. Fiber yield of these products are, of course, as I said at the beginning of the presentation, lower than the soft and the hardwood. So this kind of paper making is more suited for smaller craft type of paper mills, like you have a craft breweries. You can also have a craft type paper mills. So mainly basic runnability and printability should be enough. We had printing in offset printers, digital printers, flexo printers, and it's more or less every printer had good responses, but no very strict quality parameters regarding optical quality can be expected. So if you want to control the printing process, we had one problem with the designer who didn't know much about ICC profiles and standardization values, and was not very satisfied when the paper came out. So we also made ICC profiles on these papers. And at the end, I would point out some other problems which are, I think, very important for the printing industry. Is the color challenge. For example, as you saw, these papers are not white. So the LRB values, the delta values of the full tone will be in standards, but the tones in between will have a very distinct brown gray shade. So the whole matching based on the white point is questionable, as there is no D50 or D65 references. But our point is, as I said, brown is the new white. We have to change perspective because these papers are not washing powders, where our white is whiter than other ones' white. Why I'm telling this, there is a very interesting story. A certification organization in Germany called Blau Angel, or the Blue Angel, which is giving eco label for recycled paper producers, had a very large fight back from paper mills when they wanted to lower the whiteness limit for recycled paper from CA whiteness 135 value. That means that they wanted recycled papers to be less white, less bright. And the paper mills fought against it because a lot of paper mills would lose their certification. But people have to realize that if you want to make paper white, you have to use chemicals. You have to use optical brighteners. And people tend to class papers which have more blue components as higher grades, as a purer, better paper, and for example more yellow, I'm talking about the CLAB system, as lower grades, as a cheap grades. But these changes of preferences and the perception of appearance of the products is just in us. So it's on the designers and marketing studios. It's very important that you get rid of this classing of papers, because I think achieving ultimate white with a lot of chemicals, a lot of optical brighteners, it's not doing good to our nature and the sustainability. Maybe it's time to be a little more brown. So more brown is more greener, I can also say. So maybe we must change our preferences, and this also is going to all the standardization systems, FOGRA, G7, and everybody else, that maybe we have to rethink our appearance values. Okay, I shall finish slowly as my time is slowly up. I want to thank you all for your attention, and if you want any information or samples of these papers, or you have fibers to offer us to make new exciting products, please contact me or my colleagues from the Pulp and Paper Institute in Ljubljana. Thank you.